Okay. So homework 3 due next Thursday. I know whenever we do an extension, it kind of just throws people for a loop and people sort of mess up. But homework 3, we have not extended. It is still due next Thursday at 10 a.m. So it shouldn't be too heavy a lift, particularly after prepping for the exam. But yeah, so it is due then. And then, of course, we did push project 3 out an extra week. So you have up until the Thursday of finals week. So March 18th, also at 10 a.m. to kind of get that done. And, you know, as we mentioned at the time, depending on what your final schedule is looking like, if you're one of those that every professor had sort of front loaded all their exams and everything, and so everything comes due for you week 10, then by all means, use the grace period of finals week to try and kind of focus on the project. Alternatively, if you do have finals during finals week, we do encourage you to try to kind of wrap up all the course material ahead of time so you're not sort of overburdened. Right? Oh, not yet. Sorry. But yeah, we sort of, leave it up to you. You guys are responsible. You'll kind of take care of it. The Kaggle competition, yeah, there's a question in the chat. It's also due on the 18th. Yes. So, and we will, of course, be announcing winners for that after the 18th. So in terms of logistics for closing out the course, any questions on that? Okay, so let's talk about the exam. I think that's kind of, the main thing we're here for. And the primary content, as I mentioned, I sent out an email about this, but the main thing I wanted to sort of cover today is to review the exam. I know that the pass, no pass sort of versus letter grade decision is today. So I think a lot of you are kind of trying to make an evaluation of whether or not you want to transition or not. So hopefully today's discussion will kind of help get you there. I guess kind of a few things I want to mention, just sort of for your situational awareness. I think, and I do want to kind of pause and hear some feedback from you all in terms of how you felt the exam was in terms of difficulty, appropriateness to content, whether or not we had sort of prepped you enough, if any kind of things threw you for a curveball. I do know that on our end, we struggled a bit trying to sort of scope the questions properly, because we wanted this to be something where it was closed book, closed note, and trying to structure the questions in a way that it wasn't something that if anybody sort of tried to Google it, they couldn't, easily find the solution, right? It was something that ideally, if you had studied and prepared, you'd be able to kind of do, but if you didn't know how to do it going in, you wouldn't necessarily be able to kind of cheat your way through it. And that's why I think sort of the questions took the forms that they did. Having said that, this is the first time we've fielded an exam like that. And I think we kind of all recognize that maybe a lot of those questions could have thrown people for loops. I think particularly, we're particularly worried, frankly, about the PCA question and the decision boundary question. And so what the professor has already indicated is that we're going to sort of take a look at kind of the class performance on that and sort of reevaluate those questions based on that. To be frank, if one of those questions just, people just aren't doing well on, we may just not consider that as part of your grade for the exam, or, we may make that extra credit or something. We want to, we recognize that we weren't really able to give you guys practice exams in advance. And so as a result, I think the format of some of those questions could have thrown you all for a loop. And we do want to be sympathetic to that. The professor has also, because I know there were some questions about curving for the course and things like that. The professor has indicated that she does intend to curve the grades. What that means in terms of final distributions and where you'll fall on that, I don't know that I can necessarily give you an answer, but she kind of has emphasized that she does want, she does intend to curve this course. She does recognize that that you all are going through a lot this quarter, and I think in general, she wants to be as accommodating as possible. Now, that doesn't necessarily mean you guys are all in line for automatic A's. And I don't want to suggest otherwise, but she has indicated on multiple occasions, including in our discussions after the exam, that she does intend to curve the course. So, but yeah, I kind of just want to pause here and just kind of hear from you guys if you have anything specifically in terms of like how the exam went, or, just, I guess, some thoughts and questions about that. And again, my agenda, we do have the solutions. We are going to be posting the solutions for both the 10 a.m. and the 10 p.m. exam. So, you'll be able to go through them in detail. My goal is to go through that today in lecture as well, just to kind of, again, give you guys kind of a little bit of a sense on how you did on the exam. But yeah, so let me just pause there and kind of see what are some just feedback. Okay, so I'm seeing some stuff in the chat. Were any of the questions just like completely just stump you in terms of how they were formatted? Was anything just, you just kind of didn't know even how to approach it, or? So, okay, so the PCA one was a little bit off. Okay, yeah. So number 2, the matching one. Yeah, I think we were definitely worried about, we're definitely worried about the matching one. Yeah. Okay, so I'm seeing a lot of people talking about the PCA one and the decision boundary matching one. Yeah. Okay. I'm seeing something on ROC curves as well. Okay, sure. Boundary. The ROC curve. Okay, so that was a 10 p.m. one. So the 10 a.m. folks didn't get an ROC curve question. Okay, so 6 was the clustering one. Yeah. Okay, this intermediate question. Interaction terms. Okay. All right, so I'm seeing some stuff about interaction terms for question 1. Yeah, it's funny. So there's a comment about like no precision recall ROC. So I actually wrote out a sample question. We sort of wrote out a bank of questions, and then the professor kind of picked and chose. And so she sort of tossed that question I wrote into the 10 p.m. one. So you 10 a.m.ers didn't get a precision recall question. But yeah, so again, we're gonna, so for the decision boundary and the PCA one, I think those are the ones that were really on the fence in terms of the degree to which those are going to be included in your final grade. I think we recognize that that wasn't necessarily something you could have anticipated going in. And again, if the performance just isn't that good on those, like I said, I think the professor is very open to just changing those to being extra credit and not counting them towards your final exam grade. So, but again, we're gonna wait. We're gonna see where the grades come out. If people sort of did surprisingly well on those, then we'll keep them in. But if it just seems like across the board people struggled, we'll probably adjust accordingly. But we'll let the grades sort of speak for themselves on that. So, yeah, handwriting is not going to be fun. I can tell you that much. I always hate the handwritten portion of these things. But you know the old trick. If you don't know the answer, you just write a whole bunch of illegible scribble, and then just to let the TA just kind of assume you knew what you were talking about. That was always my go-to move whenever I was stumped. Just, you have to strategically place some like key words just so it looks like you know what you're saying. There's a whole art to it. But yeah, so I guess any other thoughts or questions on this? Okay, so, and then I did kind of want to make a pitch for next week's discussion. So, as we sort of mentioned, Materials done. We're not really covering any sort of new material for exams and whatnot. But I did sort of want to kind of open that up as an option for you. And I think in terms of feedback, there was a lot of interest in doing something more along in terms of career. And, I guess some background. So I think most of you know I'm not necessarily the most traditional grad student. So, I sort of graduated, went to grad school, got a master's, have been in industry for 10 years now, and actually sort of work full time in addition to being at UCLA now. And I guess that kind of gives me a little bit of a unique perspective compared to most of I guess, the TAs that you would be interacting with, in that, not only did I kind of have to go through the grind of internships and job applications and early career type stuff, but I'm at the point now where I'm sort of now screening applicants myself and interviewing people for jobs myself and sort of things like that. So maybe that kind of gives me a little bit of insight that I could kind of pass on. And so I tried to kind of structure this talk around things that, I wish the old adage of like, what do you wish people, when you were, when I was your age, like, what do you wish people had told you type stuff? And I think these are things that, again, I kind of wish, no one really talks about when it comes to careers and jobs. And I really wish people had. And the first thing, frankly, is just like really helping you to sort of decide what question, what type of career and what type of job is a good fit for you. And that's not sort of an obvious conversation thing, but like, I can't tell you the number of like friends and peers that, would go through the process, would leak code and would do all the technical interviews and would go the multiple rounds and would land the job offer. And then we'd be talking 6 months later and, oh yeah, they're looking for a new job again because they landed a job. They thought it was great and they absolutely hate it. And they're back on the job market. And, just imagine all of the cumulative stress involved with that. If you think you've got a job and then 6 months later, you're doing leak code again, because you got to go on a whole new round of technical interviews, right? So like, just kind of trying to ask yourself those questions up front and try to help figure out where would be a best fit for you. Talking about, I guess I want to talk about like strategies you can have to really kind of help yourself stand out and differentiate yourself in terms of applicant pools. Another thing that I think isn't really talked about effectively, but everybody tells you network, right? Everybody. I mean, that's probably been drilled into you ad nauseum, but no one really tells you what that actually looks like and how that kind of works, particularly when you're not some senior level executive, right? When you're some undergrad with a handful of internships under your belt, like who wants to network with you? So, how on earth do you actually network effectively? So talk about that. We can talk about sort of really how to do well when you get into an interview situation, how you can sort of help to stand out a little bit. And then just finally, if you have a job offer, how to negotiate it. But yeah, so that's kind of what I'm hoping to spend next week talking about. I know it's going to be week 10 and you're leading into finals, you got other stuff, but if you think it would be helpful, awesome. If not, it'll be recorded. I'll throw up the notes. But yeah, I hope it can be useful. Also, next week, I keep teasing this, but it's happening. Next week will officially be, it's basically our little CS188 prom. It's going to be our little formal black tie discussion. So yeah, I was really proud of this one when I came up with this, but literally come, now is your chance to break out your non-elastic waistbanded gear and actually wear something nice. We will be giving out awards for best dress, so do come decked out. It's time to bring out the bling, break out the bling. So yeah, that's gonna be next week. So hope it's gonna be fun, kind of nice way to sort of wrap up the quarter for us. But so yeah, and then okay, I think my next slide is just an exam review. Okay, so now I'm going to pivot over to exam review. And like I said, my goal is just to kind of specifically run through the 10 a.m. exam. I can run through some specific stuff for 10 p.m. as well. I don't want to spend too much time, again, because I recognize that you guys have a lot of stuff on your plate right now. with other classes and whatnot, but we'll try to run through this. And then I want to just kind of try to give you some time for homework project or just to hop off to other stuff. So any questions before I do that? Okay, cool. And then let me just make sure y'all are muted. Good. Okay. And let me just pull up our solution set. So again, this will be posted on CCLE this afternoon. So allow you to kind of go through it in more detail. But okay, so here is my thing. So question one, we won't necessarily go through these questions in detail unless you have some questions about the questions themselves. But this was all about sort of building a learning model and sort of interpreting it appropriately. So in this case, for the 10 a.m. one, it was looking at, so in this case, your y, the value you want to predict is the amount of growth, and you want to look at it in terms of it's going to be a linear function in terms of sunlight, which is a continuously valued variable, and plant type, which is a discrete categorical. And then, so the question is kind of how would you sort of construct a model and how would you interpret the coefficients? And so, so I think sort of the key ways in which this is going to be sort of interpreted are, so the first thing is we have the variables by themselves, but then it's sort of notable precisely because you have 3 different types of plants that it's probably useful to sort of render this in terms of an interaction term between sunlight and the presence of that particular plant or the absence of it. So, so let me see here. This could we have used? Yeah. So and let me just say this. This is I guess one possible approach. You don't, if you took a different approach to doing this. So for instance, there's a question like, what if you one-hot encoded your plant types versus an interaction term? And I think that would be fine. I'm not exactly sure what the grading rubric for this would be. I don't think, as long as you took a reasonable structure to this approach, I don't think, like, it may be, I think we may take off a couple points if we don't mention an interaction term, but I think for the most part, it would be fine without it. But again, yeah, so there totally will be partial credit. There's no, because again, this is a question that's open for interpretation, and there's no right or wrong answer for this necessarily. I think we did want to see at least a mention of an interaction term, and so maybe there'll be a point or two off for not mentioning it. But as long as you sort of reasonably walk through setting up a linear model, doing something with your categoricals, again, if it's one-hot encoding, that's great. If you do some sort of interaction term, I think that's fine. And so there's a question, does it have to be, you have to mention that explicitly? No, I think as long as you've structured it appropriately, that'll be fine. And then just kind of walking through what the various coefficients are. So, we just kind of have a right up here. So in this case, your y-intercept is the amount of growth in the absence of sunlight. And again, this is if you structured it in terms of plants type 1 and type 2, and you've dropped plant type 3. So in that case, your beta naught will be for type 3. Otherwise, it'll just be the absence of that. So, whether or not, for instance, like in this one, we just modeled this in terms of the 2 types, with the idea being that the coefficient would be the default for type 3 in the absence of it. But alternatively, if you modeled it with all 3 variables, that's also fine. We had a similar question in I believe it was homework 1. And so there was a question of, what if you included explicitly the 3rd option versus not including it? And that's fine too. Again, I don't think you would be wrong for doing that. And I think, fundamentally, if the question doesn't explicitly tell you to do something, and as long as your approach is reasonable, you should expect at least most full credit. Let's see here. Oh, okay, that did weird things. So then For question B, testing the null hypothesis for each independent variable to indicate whether or not there's a significant correlation with the dependent variable. So, again, what we're sort of looking for is some kind of written explanation here, and it's a bit open-ended here, but essentially we do want to see you sort of write out, okay, well, we would be doing hypothesis testing for each parameter. One possible method, again, we can use something like Bootstrap, and we can look at mean standard errors for a given parameter. We can use that to compute a t-statistic, and then leverage that to determine the p-value. P-value will tell us whether or not we can reject the null hypothesis. Some kind of write-up here. Again, there's going to be a lot of flexibility in terms of what we're going to look for, but we just kind of want to see you just kind of write through and explain, generally speaking, what sort of hypothesis testing would look like for you. But I think there's going to be a lot of latitude in that question precisely because it's such an open-ended prompt. So, there may be some specific points we're going to look for, but by and large, as long as you've made a reasonable description, I think you should expect to get largely full credit for that question. Any questions on number 1? Okay, cool. So moving on to decision boundary. And again, this is one that I feel like it's the kind of thing where it's actually not, if you kind of have been prompted to think about the problem in a certain way, I actually think it's not that tricky, but it's the kind of thing where you had to be in a certain mindset to think about it. And again, because we didn't prep you with that, you didn't have a example problem to say, oh, learn to think about challenges in this way. I think it ended up being more challenging than maybe we had sort of hoped for. But, but again, just kind of walking through and essentially just sort of thinking about, okay, well, each learning model has sort of particular quirks, and the particular quirk, if you kind of think through the logic of it, will manifest in a way that's sort of pretty evident in terms of the resulting thing. But again, you kind of had to be in a mindset to think in that way, and we hadn't necessarily explicitly prepared you for that. So, as an example, so for a linear SVM, so we know that it's going to be a linear divider, and we also know that it's going to look to maximize the margin between the boundaries. So looking at, okay, so this thing got kind of messed up. Where is it? Okay, so here. So we know, so for instance, we know it's going to be a linear thing. So we know realistically, it's going to be one of these three. And then we know it's going to be something that's going to try to maximize the margin between them. So it's definitely not going to be the slanted thing here. So we know it's going to be one of these two. And then, but we note here that this line is equidistant between our points, and this one slants a little bit down. And so for an SVM, because it tries to maximize the margin between our clusters, we know it's going to be sort of this one. So that's kind of how you arrive at that first point. Then number 2, so a kernelized SVM. So this one's going to be tricky. And I'm not going to lie, when I was trying to solve this, I also was like, where does this one go? This doesn't really make sense. But so we do know that that sort of it's a polynomial order 2. So we know that it's going to be curved. There's going to be sort of a contoured element to that. Is kind of the first thing to note with that. We also note that because it's sort of on multi-dimensional space, it could be the kind of thing where it doesn't, in terms of when we're looking at it in a 2D space, it may not look like it's a sensible decision boundary, but that's only because it's sort of a higher order dimension that's kind of then sort of visually dimensionally compressed into a lower boundary. So, but I will tell you that was kind of, for me at least, that was a process of elimination thing. I pretty much kind of went through, I was like, okay, realistically it could, it has to be something that's contoured. None of these other ones would be a second order polynomial. So it kind of has to be that one, but that one kind of looks weird. And what kind of decision boundary is that? But maybe it's the kind of thing, again, that it's like a higher order thing. So like I ended up, by process of elimination, you sort of end up there, but that one's probably the trickiest one. So, you know, and again, there's just kind of a process of elimination to get to getting to that one. Perceptron. So again, perceptron is the kind of thing where, you know, it's one of the quirks of the model. We know that a perceptron will continue training until it achieves sort of a clean delineation between the clusters, right? That's when convergence occurs. But I think the key point to a perceptron versus, let's say, some of the other ones is that there's no optimization of it beyond that. You know, there's nothing in the perceptron to sort of train it to maximize the margin, right? To minimize its loss function, do something like that. So as long as it achieves a clean break, it can be completely arbitrary, and it'll just be fine. And so, you know, it's kind of like recognizing that nuance tells you, okay, B would be an example of that, right? Where it does clearly do a clean break, but there's no optimization about that clean break. It just happens to have achieved that. So in contrast, you know, going to for logistic regression. So if you remember here, we are trying to minimize the loss function. And the loss function is really sort of looking at each individual point. And so because of that, this is kind of where I think the little bit of nuance comes. Because we have so many more of our red X category than our blue circle category, it tells you that if I'm trying to minimize my loss function, I'm going to sort of bias away from my red thing. I'm going to give my red X categories a healthier margin to try and kind of minimize my overall loss. And that's why this line sort of skews a little bit down. And that's the difference between an SVM and a logistical thing. Whereas SVM just tries to maximize the physical geospatial margin. And this one tries to minimize the loss function, which means, again, it'll bias away from its decision boundary, away from a sort of a higher number of classes. So that was kind of, I guess, the trick to that one. So decision trees. So we know sort of for decision trees. So again, and so there's a question, could it be a perceptron? Yes. So it could have been a perceptron. And I think, again, sort of the key distinction between sort of a perceptron and this one is that a perceptron, all we know for sure for a perceptron is it'll run until it achieves a clean separation. But there's no effort within that to maximize the result. And I think that's kind of the insight for why this one would be more appropriate for a perceptron. Because this is clearly, there's nothing optimized about this. It just happens to be a clean division. So, but again, you know, like I said, I highly suspect that this was, it's just kind of a way of thinking about models and how they make their decision boundaries. And it's not something we really prepped you to do. So we're not really anticipating that a lot of you did well on that. So if you kind of feel like you flubbed this, we're sort of anticipating most people did. And so, and again, like I said at the outset, we are probably going to reevaluate this question just based on people's performance. So for decision trees, so we know because those are sort of binary decision points and sort of multiple cascades, so we know it's going to be sort of straight lines in terms of how that visualizes. So again, we know we're going to look at something that's kind of like a straight line thing based on your various features, sort of where you draw those dividers. And then in terms of sort of just doing a distinction between a decision tree and a random forest is that whereas a decision tree should be sort of overall by feature, because for random forest, you're taking sort of an aggregation. We know it'll be piecewise straight, but the overall sort of effect, because you're averaging out performance across trees, may end up getting something a little choppier like this. So again, it'll still be a piecewise straight thing, but the overall effect of it will be choppier. And then the final thing, sort of, we have the two neural nets. And again, it's just kind of thinking through the different activation functions and how they may impact the resulting decision curve. And so I pulled up something here. So just, really quickly. So tan-H, if you recall, compresses real valued, your real valued outputs to a -1 to 1, but it's still sort of a rounded, curved sort of output thing. So you still get things on a bit of a slope, which is why if I'm looking at this, okay, so probably something like this, which is rounded, is still probably appropriate. Whereas, where's my ReLU? So here, right, because you have a very kind of discrete boundary thing where it just outputs a 0 if less than or equal to 0, and then whatever the z value is if greater than. So we know that that's going to be kind of a squared off boundary. So it's going to be much harder boundaries. So again, that's kind of the thought process. It's, if you're in the mindset where you're kind of thinking about those models in that way, I think it's not necessarily too tricky, but again, it's just a question of sort of what to expect for it. And if you hadn't sort of been anticipating that kind of question, I don't know that you would have necessarily done well. So let me just kind of pause there. I'm seeing some chat seeing some discussion in the chat, but just like any other, I guess, specific questions on number 2?
What exactly is a contour shape?
Yeah, so a contour shape is because it's sort of a second order thing. So think about like a x squared. Where's my? Okay. So you would expect where is it? Sorry. So you would expect some kind of rounded thing, but you wouldn't necessarily expect, so a contour is sort of a rounded thing, but you wouldn't expect it to be sort of a multiple thing, right? For that, you would need a higher order polynomial to kind of achieve something that looks more like so. So, and again, that one really is, that one was definitely the most challenging one. When I was kind of working through it, for me, that was really just process of elimination, of saying, well, nothing else really makes sense, so I guess it must be that one. But yeah, I wasn't particularly loving that one either. Okay, and so 3, our PCA. So, again, the sort of the key insight here is just sort of thinking about how, right, in general, the sort of the first principal component is going to be the data, is going to be sort of the axes that capture sort of the maximal variance across your data set. And so it's just kind of looking at these patterns and saying, okay, well, looking at how these different clusters of data overall, how they distribute in a way that kind of impacts the relative variance. And so this one here is the most obvious one, right? Right along that axis there, kind of makes sense. This one throws you for a little loop because you have these two axes. But again, if you kind of look at the overall variance, you can see that here really our data spans from here to here. So we're really looking at an axis more along this line in terms of the data. Kind of a similar thing here. Yes, we have these two discrete clusters, but as a result, if you look at like the variance, again, sort of really along this axis is kind of the biggest sort of explainer of variance for it. And then lastly, I think the sort of the nuance here is because each of these clusters has an equal number of points, but this one is compressed here. So that kind of flattens this thing down really to that element. And in some ways, it's very similar to this one as well. So let's see. So yeah, so again, the PCA question is going to be another kind of thing where we really don't know how class performance is going to be. It's the kind of thing where if you walked in and you sort of had the insight of saying, okay, well, let me try to kind of look at where the plot the line that sort of is the axis of maximal variance, then it's not necessarily that difficult a question, but you had to be in the mindset to do it. And I think we are going to try to give at least partial credit for that. I think we recognize that obviously it's not going to be sort of an advanced precise measure, right? You're just simply eyeballing these. So, by the way, for those of you keeping score at home, this is a whole wheat veggie bun, which is awesome. And I got some turkey. Yeah, so there is a question about how much these questions are going to be worth. We have a suggested rubric, but again, part of what we're going to be doing, part of what we're going to be assessing in terms of your outputs is just looking at how people's performance is and then potentially weighing the points as well. So, I mentioned like one thing we might do is just kind of make the questions extra credit. Another thing we might do is just de-emphasize it. So, if nobody really did well in the PCA question, maybe we just kind of make that worth a fraction of what the other questions are worth. So we're leaving us, that's why there isn't sort of a firm, oh, this question is worth, 20% of your exam, all questions are worth equal. We're really just kind of playing around with that to just kind of make sure that, I guess, the exam ultimately is fair. So, there will be a sort of a final rubric released, but for the moment, we want to allow ourselves a little flexibility. So the cauliflower is coming. I know you all are waiting with bated breath for that, but it's coming. Okay, so that was PCA. Okay, so bias, variance, and regularization. So, okay, so the first question had said, like, you were given these three. Where's the graph? You were given these three, and you were asked to say, okay, which sort of model shows an overly high amount of bias, which one shows too much variance, and how is that going to impact, as these models train over time, how are you going to sort of see a change in sort of performance over time between both your training and your testing / validation model? So, if you'll remember, just I guess kind of at a high level, because we sort of run through this, but there's always this Goldilocks approach to data science, which says, we know that the data that we're given is not fully and entirely representative of the universe of data. And so generally we want to hit a sweet spot where we try to kind of learn the general patterns of our data and build a model that's pretty universal. But at the same time, we don't want to sort of create something that just really kind of conforms to the peculiar sort of quirks of what your data set happens to be, and effectively overfits to it and creates a model that really doesn't generalize well. And so, bias being the idea, so variance being the idea that you overtrain your model to the point where you're no longer just capturing those general trends, but you're now capturing just every kind of quirk or outlier or noise in your data set. And bias being the idea that you undertrain, that you sort of make these broad-based assumptions about your data that really don't sort of bear out in terms of your data. So, looking at these models, obviously A is a function of bias, C is a function of variance, and B is more sort of a nicer kind of approach to it. So yeah, so there's a question in the thing about, is it fine if we just plotted model complexity versus error? Yeah, so I think, because that one was a little vague, I think you'd be fine if you produced that one as well. I think because again, we didn't sort of give you a precise thing for what we wanted our X and Y axes to be. So I think you'd be justified in saying, that's a reasonable thing to assume. So then in terms of sort of how the data looks, how it trains over time. So the way we have here is we're looking at error over time, and epoch is the amount of training intervals. And so, the easy one here is C, which is the overfitting. So as we overfit, we obviously kind of fit our model to our training data. So our training error goes down, 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 whereas our validation error really kind of flattens and even, I would even argue, tends to actually go up. So I think this is actually not fully accurate, because as you begin to overfit, your error due to variance goes up. So this should actually go up over time. But that's generally what that one looks like. A is kind of the exact opposite. We sort of get lazy with our approach. We sort of stop trying to fit it. And so after a while, we're sort of just uniformly making the same kind of bias errors in both our training and our validation data sets. B is sort of the ideal one, where we kind of learn a model of it and we sort of reduce our training thing, but more importantly, we're continuing to sort of reduce our validation data set error as well. So these aren't precise things, but generally speaking, we'd want to see kind of trends like this over time, and just kind of understanding how, as you continue to train, it'll impact your error over time. So any questions about that? Okay, so there's error versus epoch graphs, and then showed what point in the graph algorithm was currently at. Yeah, so so I agree. There's some ambiguity for that. So I think we would definitely award some partial credit for that. Yeah, so again, good question. I think the idea was that these were supposed to represent sort of converged models, that these were supposed to represent finalized models, not sort of in-process models. But yeah, you could obviously look at this as a sequential thing where it starts, it's training, and then it's converged. But so yeah, I think we would have, I think I'm glad that I'm getting that feedback, because I think, we'll have to be aware of that when we're looking to train or we're looking to grade. Oh, baby. Is this my cauliflower?
It's too small. I can't find it.
Okay, y'all, hang on. Let me stop sharing. Get to put my lunch on cam here. Where is it? Where is it? Look at that spread, y'all. Oh yeah, and I got myself a yogurt. Okay. See, now it's a party. All right, let's go back to this. So, okay. Oh. Yeah, little Savannah's spoon and plates. They're still clean, so I only get to use them once she's used them, but she hasn't had her solids yet today. So sadly, that's a nighttime indulgence on my part. I'm stuck with the boring grown-up plates. But yeah, I guess just to kind of close the loop on this, one note that I'm going to take from this discussion is I think there was a lot of ambiguity in terms of how that question was worded. And I think people kind of weren't necessarily certain what was being asked. And maybe when we're grading that question, we need to be a little bit flexible in terms of kind of how we apportion grades and what we're looking for. So that is a note that I'm going to take. And when we're grading, I think we're going to adjust our metric rubric accordingly. Then for part B, you are asked about sort of the different sort of regularizations, the L1, the L2, right? Lasso versus ridge. And then you're given two figures. And in which figure does it seem to indicate that there's an L1 regularization, and why? Okay, so let's go back down there. So what is an L1 versus an L2? So an L1 is where we try to kind of zero out the coefficients, and by sort of just penalizing the general magnitude of the coefficients. And so we try to zero them out. So that's what we know about what an L1 looks like. Now, in terms of, and it's a little bit kind of difficult to see, so let me sort of zoom in here. So if the blue line is our original line and our black line is our transform line, Well, in one of them, we sort of see that this dimension seems to be flattening out. So it doesn't seem to kind of be having much of an impact along this axis, whereas here, if anything, the slope is increasing. And so generally what you could say there, okay, is whatever the dimension is along there, it seems to be zeroing out because whatever the coefficient is associated with that slope seems to be zeroing out. So, just kind of looking at it, that suggests that that is the impact, or that's the result of an L1 regularization. So again, not hopefully too tricky. It's just sort of knowing L1 means zeroing out coefficients. Coefficients generally means you flatten out in terms of certain axes, and just seeing kind of which one is flattened out compared to the others.
Can I ask a question?
Yes, please.
So I thought that like, because in A, the line was like flattening out, but it wasn't like 0. It's L1. I just remember the graph, like it just drives the coefficients completely to 0 if you increase the penalty. And I thought that it might be ridge, because I remember that like, or not ridge, but I guess L2, because I remember that L2 is like a more harsh regularization penalty because of it has the square term, but then it makes things really small. It's not able to drive them to 0. And I thought that since L2 is so much harsher, it could be A. And since it's non-zero, it could also be.
Yeah, so I think that's a fair point. So yeah, so just to confirm, an L1 will zero out generally. So both L1 and L2 will minimize the magnitude of the coefficient. With an L1, though, it'll sort of tend to actually sort of zero it out entirely, whereas an L2 will tend to optimize around just minimizing without actually zeroing out. And that's just simply because if you're looking to sort of maximize your, or in this case, minimize your overall loss function, because you're not squaring something, you don't actually need to zero it out in terms of improving overall performance. So I think, so to your point, I think if you looked at this and said, well, could A be an L2 as well? You're probably right? If I say like, which one's an L2? Well, you could say, yeah, the coefficient along the axis seems to be minimized. That's what an L2 does. So that makes sense. I think sort of the key there is that there's no question that B does not reflect either an L1 or an L2. And so, and again, I recognize that that's a little bit confusing in terms of how that question was framed, but I think it's safe to say, like, if you look at these and say, well, which one of these two graphs has a regularization strategy been applied? I think most people would agree that A is the more sort of obvious one where there's some kind of regularization. Whereas B, your slope is more pronounced. It's sort of more aggravated versus your original line. I don't think there's really as easy an argument to be made to say that that's the result of a regularization. But you're right to say it could have been an R2 or an L2 as well. Yes. Yeah.
Did the problem say that? Oh man, I must have misinterpreted the.
Oh yeah. Yeah. So in which figure is L1 regularization used in Y? So yeah, I realized because we ask in the description about L1 or L2. So maybe some people, did anyone else kind of make that mistake of trying to match each one to each and say one is L1, one is L2? Okay, so I'm seeing a couple. Okay, so that'll be a note that we'll take back as well to the professor, that a lot of people sort of interpreted that as a matching thing. Yeah. Yeah, I agree. I feel like we kind of shot ourselves in the foot by having that whole description of L1 and L2 regularization and then putting the two things. So, okay. So again, that's a note that we're going to take back because, we recognize that I think it would be easy to interpret that question as being which one's L1, which one's L2, and not just looking at and saying which one has a regularization strategy been applied to. So I will take that back and as a potential consideration. Okay, so we get to perceptron. So in this one, I also kind of screwed this one up a little bit because I'd actually written this one out originally, but I had actually in the question said that along with the constant are initially set to 1, and then people were asking like, hey, is there a bias term for this? And I was like, wait a second, I meant to do bias, and then I'd forgotten I had written constant there. So we ended up with this kind of split thing where some of you solved it with the bias term and some of you solved it without, and both are ultimately acceptable. And I think, and it will, working through the math a little bit, I think it does impact the update rule for this one, for the second one, because if you have the bias term, you would update. If you don't, you wouldn't. But the first one I don't think gets changed, and I haven't thought through about the third one, but essentially we'll accept either one as an acceptable solution. And then of course, it's very similar to, so you don't need to have, the table doesn't need to be precisely the same. What we really need to do to evaluate this question is we need to see the weights and how they update, and then we need to see your prediction. Those are really the ones we need to do. Just to make it easier, I include the sum table there just to kind of make it easy. Is the sum supposed to be 3 for the second row? Oh, wait a second, did I do this? Yeah, sorry, it is supposed to be 3. Thank you for catching that. Yes, yeah, so it's 20, negative 20, and then 3. So yes, sorry, the sum is 3. Let me take a note about that. Okay. Well, okay. I'll just write. I'll note to make that fix. But yeah, sorry. So that sum should be 3. This is what happens when you write out a solution guide at 2 in the morning. And then so if there are arithmetic errors for this one, you will for sure get partial credit. We really just want to kind of see that you know how to do this. You understand how the perceptron works. Like we want to see that you know kind of generally how this rule works, right? The delta and the weight is your original plus your running rate times a differential times the magnitude of your x term, right? As long as you kind of apply that, if you make some errors along the way, we will take some points off, but it won't be terminal for doing so. So any questions specifically on this one? All right. So now we get to clustering. And this is one of those questions that I think is worded in a very sort of confusing manner. There's a lot to unpack there. But once you kind of unpack it, it's a fairly straightforward thing. The challenge with this is just sort of unpacking all of what you're given for this. And so you're provided a data set. You have these 2 clusters associated with it, CS1 and 2. And then there's a radius of 1 centered at, so whatever your D is, which is your point away on the x-axis, and then the radius associated with that, and then this. So where do we have? Oh, I'm trying to scroll through to it. No, that's not okay. Right. So there's whatever this D is, which is our separation from it, and then we have our radius of 1. And so that's sort of the total distance from there. And both of them lie directly on the x-axis, so our y value is going to be 0. So that's what we're given for that one. Okay, sorry. Let me just scroll back to. Okay. So, right, and then it sort of walks through the k-means, and here we're doing a batched approach. So we initialize our clusters at some value u, and we have a certain number of clusters k. We compute the relative distances, and then we assign points to the nearest cluster center, and then based on that assignment, we then update. And so then the first question is, so we have this sort of mean value here of a particular cluster. So that's sort of the mean of that value within that. And then, okay, if we initialize, okay, so what is this specifically asking with you? Yeah, so if we have that mean and we initialize our, all right, let me make sure I'm answering the right question for this. Okay, so that's what we. Okay, so essentially, so we have our mean values here. This is our x values. And then we're going to say that if we initiate, so we're going to randomly, the C is going to be sort of our random. So if the mean as compared to the sort of the center of our radius is less than that D, so if this is D, we have that C point, which is there, and somewhere along the lines, we have our X1 or X2 values. So you can see that there. So we're saying if it happens to be that the average of this entire thing, this space here is less than D, prove that this will converge after a single epoch. So after sort of a single round. And so again, this is just kind of a very simple logic where you sort of work through the assumption, and you can kind of basically show that because this assumption holds true, even the values that will sort of be furthest away will still fall within this centroid. And so will naturally be closer to this than they could possibly be closer to that. And so they have to be assigned to here. And so there'll be no sort of shuffling of points. And so your thing will have converged after that first thing. And so it's just kind of writing through the logic. And again, the key element there is saying because the distance between your mean and your center is less than that, then that sort of fact has to hold. So, and then it says, okay, well, what if you don't necessarily, so then number 2 is kind of a build off of that. And it says, well, okay, well, what if you don't necessarily initialize at the mean, but what if you initialize at any random point within your centroid, but you can just assume that D is large enough. And then again, there's just kind of basically a logic to that says that if D is large enough, then that says that these centroids are going to be far enough away that even if you initialize at the most extreme point here, any point within here, if D is big enough, will still be far enough away from that such that this will always be assigned here. So it doesn't really matter as long as you're within there, you'll still get it assigned. And then yeah, all we're asking for is a simple explanation. So we write out a more formalized thing, but this is really just a logical thing. So you wouldn't necessarily need a formalized proof for this. Let me just look through here. Yeah, again, the fact that we're asking, give a simple explanation. So you're fine. We really don't need a mathematical formulation. If you want to provide that specificity, that's great, but you really don't necessarily need to. For part A, I think as long as you demonstrate that it's clear, we haven't asked for a detailed proof, and so I think you should be all right. for that one as well. And then for part C, obviously k-means is very, okay. So there's a question of what's the difference between x mean and ck. So ck is what your cluster is assigned to. So ck is, okay, so ck is the center of your, where is the figure? It's the geographic center. So here, if you look here, it's sort of the center of your radius, whereas it's not necessarily the mean value of all the points within it, right? If all of your points cluster along here, your mean may be here, even if all of them fall within that. So that's the difference between C and, in this case, your mean value. And then for C, I know the professor in lecture had sort of talked about some of the downsides of these, and obviously k-means is very susceptible to outliers. And how in ways around that. So just kind of writing out just any, I know she sort of mentioned these in class. So, hopefully you were kind of able to just recall something that she had mentioned, a method that you could use as an alternative that sort of addresses outliers and sort of explicitly weights things. So like DB scan is a method that does that, where it sort of disproportionately weighs outliers and things that are geographically more sparse. It weighs them less heavily. So that is the 10A in a nutshell. So okay, k-medians work. That's a good question. I think it would work because that's your 50th percentile value. So offhand, I think that would address that. Yes, because again, mean as a particular thing is very susceptible to outliers, but a median value should be much less susceptible to that. It look like for this data, do I have something? Oh yeah, okay. So I think, okay, so here's like an example of this. So the professor even provides us an example of this, where like here you see, because there's this sort of weird clustering thing here that's an outlier. So if you did k-means, it would sort of create this kind of separation. And so you'd get a lot of overlap here where there shouldn't be. Whereas a DB scan would correct for sort of relative density and would sort of properly draw the circles this way. So Belle, I have to confess, I don't know what a mean shift is. I don't know if you want to specify. Oh, okay. Oh, I think so. Then yeah, I think because again, the whole point is you want to sort of place less emphasis on outliers in terms of how you position that. So a mean shift says, don't calculate your mean based on those outlier values, which it sounds like what you would effectively do. Then yeah, I think that would address that. Yeah. So yeah, and again, there isn't a right answer to that necessarily. I think it's just recognizing that mean as a statistical measure is very susceptible to these outlier issues. And so any kind of approach that explicitly sort of tries to correct for that, you'd probably be looking at full credit for that question. There isn't one right response to that. Okay, so that was 10 a.m. I know I think there's at least one person who was on for the 10 p.m. one, and God have mercy on you for coming to discussion after being up for that. But is there anything in particular you want to review in terms of 10 p.m.? Because I can pull that up. Is it fine if we classified the line as noise? So Ricky, I'm not sure what you're asking with that. Yeah, absolutely. Yes. I think that would be fine. Again, there isn't a right or wrong approach as long as there's an explicit attempt to do that. So there weren't really, and I think somebody who took the okay, for 10 a.m. Okay, Q3 and Q5.2. All right, give me a second. I can try to pull those up. We tried to make these as equivalent as possible. Obviously, there were some differences, but we did try to make them pretty equivalent. So let me look at the PM one. And then, okay, let me pull that up and then compile. Oh, wait, no, so I need PM solutions. Okay, so we have. So three. Oh, you know what? I don't have. I don't have the solution for the PCA question yet. So they were given a different type of PCA question. So I don't have the solution for that one solved yet, but we will be posting that. And then 5.2. Oh, so 5.2 is for the F1 score? Oh, for the ROC. Oh, 5.2 is the ROC curve. Okay, yeah, sure. So I would have to model that. Okay, but let me, so we actually haven't fully done the guide, but I can sort of just show that to you really quickly. So for the ROC curve, so you're given a probability table and you're given sort of, and so this is the probability of a positive label, of a label equaling to 1. And then you're given, what the actual label is. So that tells you if it's a true positive or a false positive. And so, and there's 4 values of each. And then the ROC curve is really just the ratio of true to false. And so in this case, if you're looking at this, essentially half of your true positives will go in before your first false positive will go in. And so like if you're graphing that, you'll sort of go straight up to about the 0.5 line. And then you'll shift out 0.25 for your first false positive. Then you'll go up to 0.75 for your next true positive. Then you go to 0.5 for your false positive. Then you'll go up to 1 for your true positive, and then flat line over for your false positives. And then from there, it's just a question of calculating the AUC, which is just a basic geometric calculation for that. Yeah, absolutely. And that reminds me, I do have to write up the solution for that one. So 10 a.m.ers, that's the fun that you missed. So that is the exam in a nutshell. I guess, so let me pause there and see if there are any questions on it. Okay, and again, these solutions, these PDFs will be posted on CCLE this afternoon, so you guys can take another look prior to you sort of making a decision, pass, no pass for the course, because we do recognize, I think it's 5 p.m. That's the deadline to make that decision. So we will get you that up there prior to that. And again, I know there's a bit of ambiguity about what the score will be, precisely because we're gonna sort of be open in terms of our grading and our things based on how people are doing and how they interpreted problems. So I think the feedback I got from you all was really helpful, because I think, again, we'll probably adjust accordingly. So yeah, anything else? So she hasn't sort of defined, so there's a question in the chat about sort of a precise curve for the class. She hasn't articulated sort of a precise thing. She hasn't said, oh, you know, I want 50% of the students to get a B plus and 25% to get, like, she hasn't articulated anything like that. The only thing that she's explicitly said is that she does intend to curve the grade up, and you know, she recognizes kind of how challenging this quarter has been for everyone, and just kind of wants to, and the grade, ultimately the grade distribution will reflect that. So, but no, she has not given us a precise kind of metric for that. So if it uses, yeah, so Ricky, she has not given us any precise numbers on that. So unfortunately, I can't convey any of that to you in terms of that, other than that she has explicitly stated that she does intend to curve. Okay, well, are the percentages for each assignment set, or does she have any plans on weighting some assignments differently? Those I think are pretty set. I think yeah, those I don't think we're going to change in terms of the syllabus. Again, particularly like within the exam, we're going to be flexible in terms of how we weigh those, but I don't think there's any intention to change that. I mean, having said that, if there was a compelling reason to, you know, we wouldn't be opposed to that. But yeah, she would, and yeah, she will definitely not down curve. She's indicated as much. She's not going to impose a mandatory curve that says if the average in the course is a 95, that's going to be a B, right? She's not going to do that. She's been very explicit about that. Okay, so that concludes the formal sort of agenda for this discussion. I sort of want to just kind of open up now to see if anybody has any homework or project related questions. Or, you know, course questions or life questions or anything.
Do you think you can go over like the project, like the columns?
Oh yeah, okay, sure.
Confusing because there's so much information.
Yeah. So let me pull up the thing, and I'll be honest with you, I kind of haven't looked at the project since we threw it up a couple weeks ago. So I have to be honest, I'm okay, but I will try and do that. And I will mention that I'm going to try to get Fiona to come out we're going to announce it in advance, but I'm going to try to get her to come to at least one of the office hours next week, and then potentially also join us for one or more of the discussion sections as well.
Okay.
Because ultimately she's the one who can kind of do a better job explaining that. But so let me kind of pull up our little data dictionary here. And yeah, so this is, if you haven't looked at it yet, so let me just share screen. Okay, so if you haven't sort of pulled up the final project description, so we do have way back here, we have a sort of a data dictionary that will give you kind of the field name and a description of what's included. So, and I think sort of the first and most basic thing is what each row is. And each row is sort of a specific engagement on the platform. It's a specific time that a driver sort of engages I guess kind of matches with a load through the platform. So that sort of tells you something important, which is the first thing is that you may get a one-to-many approach where you can get sort of one driver ID may have multiple instances. So that's kind of an important thing to note right there. And then the other thing that's kind of important to note with that is that in terms of your approach to this, there may be some very useful information that can be gleaned in terms of augmenting your features by doing some kind of feature counts or some kind of feature aggregation strategy when you have something like this. Because remember, ultimately, you are looking at trying to build a predictive model for drivers, but the data that you're given is in terms of sort of interactions through a platform, which is, which is very typical, right? You can imagine, like, if you're on an e-commerce site like Amazon, your data may come in terms of shopping experiences, but you want to build a predictive model for the shopper themselves. And so a really, really useful data augmentation strategy is saying, okay, well, if we look at this, there are sort of biographical information that are that don't vary, but there's sort of a lot of specific stuff that potentially do vary based on kind of things. So, so like one thing that we may have to do, for instance, is, let me see, is this, so like one thing, and I haven't looked into the data specifically, but like, number of loads a driver has serviced. Well, it's quite plausible that, if they have multiple instances over time, or actually that's a question I'll take back to Fiona. Does that, so let's say there's 3 sort of transactions with that driver over time. Does that loads change, update as the driver gets more, or is that loads just kind of like a final summary value? So actually, sorry, let me take a note to deal with that, because that actually is a really, really useful question. Because that could kind of mess up a lot of these predictive models if we don't correct for that. There's loads, cumulative or additive. Okay, so I guess that's kind of, again, the first thing to note. Date is, this is just the date of the interaction. Weekday is day of the week. Again, that's sort of a categorical you may want to do something with. You may also want to kind of try to block that in terms of week or weekend, early week, midweek, end of week, right? There could be some kind of categorical manipulation. You may want to do that column. Year. Carried on for carried how many feet, one carrier can have multiple drivers. Okay, so these are kind of probably also relatively useful, and you're probably going to want to do something with these. And let's look at this thing first. So sort of one of the things Fiona kind of explained is that you're really looking at 2 types of delivery drivers. You're looking at either sort of owner operators, which basically means the person literally just owns their big rig and is a contractor. The other one is a driver for a fleet. So there's a company that owns a fleet of vehicles, sort of manages them, maintains them, services them, and then you're a driver as part of that. Then it seems like for this, if you are a driver for a fleet, you would have a separate carrier number ID. If you're an independent driver, then it appears that it is distinct. So, you definitely will want to do something with this column. It's questionable whether or not you want to do something with this column, because this just kind of gives you a unique ID per carrier. Actually, you probably will, now that I think about it, because it's it's probably useful information, not just to say that you are a driver for, for a fleet driver, but which fleet you're a driver for. So I think that kind of makes sense. You also are given carrier company name. So that is, I think that kind of relates to the carrier ID number. So you can probably keep one or the other. Again, if you're working for a fleet, you kind of want to notate that, but so you may want to do some kind of categorical encoding to this, or you might just want to drop this and just keep the carrier number. But those are definitely related. Home base, city and state, where the person is based out of. Again, probably useful in terms of predicting sort of how responsive they're going to be, just simply because we know that Next operates out of Port of Los Angeles in Long Beach. And so if this driver happens to be based out of Seattle, Washington, it's possible that they did some kind of long haul down to LA and then picked up something on the way back, but chances are they're not going to be a regular, right? So you can see these being sort of really important predictors. But again, you're going to kind of have to figure out a strategy for how you want to handle those categoricals, because cities and states can obviously be you can have just so many. States, obviously, you can have theoretically up to 50, and cities, you can have God knows how many. So, you may have to come up with some kind of sort of batching approach to dealing with that. Carrier trucks. Yeah, so this also will tell you kind of that this is a categorical that will walk you through like the type of trucks that fleet has. And again, so she notes, she does walk through in the company intro the information that she's the type of things you have. That's probably useful in terms of making some predictions. Same thing with the number of trucks could be useful. Interested in drayage. So drayage, if I'm reading this correctly, is just kind of short distance hauling. So, there's obviously long distance hauling, cross state, cross country, and then there's just kind of the short distance. The example she gives is from the port terminal to a customer warehouse. Obviously, somebody who is interested in that is probably more likely to accept a wider variety of jobs than somebody who isn't. So that's probably going to be a useful thing. Same thing with port qualified. You apparently need to be licensed to operate within a port terminal. Clearly, a driver that's port qualified will be capable of taking more jobs than somebody who isn't. Sign up source is one of those interesting kind of things where, so this is where sort of how they signed up for the platform, but it could be indicative of something interesting. That's one of those features that there may be sort of an underlying statistical feature that isn't explicitly captured in your model, but this could be indicative of. And specifically, I'm thinking age. Because, if you're paper versus web versus mobile, that speaks to the modality that you're most comfortable with, how you navigate. And again, that will probably correlate very closely to age, and age will probably correlate very closely to your willingness to take on and your capacity to take on certain jobs. So that's one of those like interesting things that at first you're like, that doesn't seem like that's a meaningful feature, but that actually might prove to be really meaningful. So then we have some timestamps. So we have a timestamp for when they initially sign up for the platform, when they get approved. There might be kind of an interesting, if you're looking for a feature augmentation, there might be an interesting relationship between these. In that, if there's a significant lag time between sign up and approval, maybe that indicates an underlying problem. Maybe there's a reason why that application was kind of slow rolled, or there was some added scrutiny added to it. So if you wanted to play around with that, just like looking through that, that's something like if you're looking to do a feature augmentation, that could be like a really cool thing of just doing like what's the, what's the delta in those? Days to sign up to approval. If a carrier was approved, this will be a non-hours kind of. Oh, okay, never mind. They just augmented it for us. Yeah, so I don't know. So yeah, so that was, okay, so then never mind. So then you may want to look at those individually. You may want to drop those, but, or you may want to use some concert of those. I don't know what Twig insurance is, but again, probably relevant because that's probably some kind of insurance that will sort of enable you to take different, maybe sort of more volatile loads, more dangerous loads. You might be able to kind of have, if you have that insurance. I think the documentation will probably talk through that Specify which lanes or routes he'd like to take. I'd have to look at what the outputs are. That would be an interesting thing if we look at like what the unique values are for that, because I don't know what that looks like. So I don't even know how we would, I mean, that could potentially be very useful. What routes they prefer, because clearly a driver who's more open for doing more routes will theoretically get more jobs, but I have absolutely no idea how that data is represented or how we could kind of package that data. First load date is sort of an obvious one for the driver's number of years of experience. Most recent load date is sort of an obvious one for sort of how active they've been. And in fact, we use most recent load date as part of kind of building out your label. We use recent load and we use loads for your label. Load day, the date of the load serviced. How does that work? So we'd have that's another one I don't really know how that works. We would have to look at that. Like, is it just sort of, if there's 3 loads, does that one tell you, sort of, does it list out the 3 loads? We'd have to sort of output those values and take a look at what that's telling us, because I don't really know. Marketplace loads OTR and OTR type of the loads covered by driver. Okay, and so then this one kind of does a breakdown of, so I guess there's sort of 2 within the marketplace. There's sort of different types of loads. And there's loads that are processed in the marketplace. There are loads that are handled brokerage. And it appears that there's OTR, which is over the road, which I think are longer distance. And then there are Atlas, which is, I think, dry edge types. And so this is just a breakdown of like what the type of, the number of sort of loads that are obtained in different capacities. And again, I think that those are probably going to be useful in terms of predicting a driver behavior. Where are they sourcing their loads? It's not just the number of loads, but where are they sourcing them? And of course, then there's a sum of like, how many total loads have they gotten in the marketplace versus through a brokerage service. So, and marketplace is their app. It's the next thing. Brokerage is a third-party broker. So, and then I think another thing that we'll need to sort of get clarity on is, because there's loads, which is the total number of loads a driver serviced. Is that different than total loads? Which theoretically it shouldn't, but maybe it is. So that's the data in a nutshell. Is that helpful?
Yeah, thank you.
And again, hopefully kind of one thing that is obvious is that there isn't a right or wrong approach to this, obviously. It's up to you and your team to kind of decide what data you want to include in your model and what transformations you want to do with it. So it's really kind of up to you, and I would expect every team is going to take a slightly different approach to this. And another obvious thing, just kind of looking at it, is that clearly, we will need to kind of look at, there are a number of these where you do sort of have to output individual instances and get clarity on these things. But when it comes to sort of data science, it's a very typical challenge, is just kind of as a first step, drilling through and saying, okay, what is the data that you're given and what can we do with that data? What's meaningful about it? So this is sort of, typically this is when you're doing a data science project, this is very typically what like one of the first steps is doing this deep dive. And then based on that deep dive, coming up with some potential strategies for leveraging it. So yeah, any other questions? Project, homework, life. This is your time. Did we go over? Okay, there's a question. Did we go over part B of the perceptron question? Oh, Ricky, great call, man. We did not. Okay, so yeah, okay, cool. Thank you. I will go over it right now. Dude, thank you for calling me out on that. Okay, so part B is asking. Let me share my screen. Okay, so it's just asking, so perceptron convergence theorem says that, if a clean division is possible, eventually the perceptron, if it's sort of allowed to run to conclusion, it will eventually sort of find a convergence point. And so our question is, based on how your model has trained, has it converged on a solution? If not, would you expect it to if you trained it for additional epochs? And the key insight, if you go back to our data, is rows 1 and 3. So if you look here, sort of the key note here is that you have the exact same x values, x1 and x2, 2 and -3, but the labels are different. You have a y of 1 and a y of 0. And there's a number of reasons why that might happen, but the natural result of that says your model's never going to successfully converge, because if it converges on a model that cleanly predicts this one, by definition, it will make a mistake here and will need to be updated, and vice versa. So that was kind of the key thing there that we were hoping to catch, that it's impossible for this model, given that data, to converge. Okay, cool. Yeah, thank you for prompting on that, because I did not address that.
I have a quick question about homework 3. I think it's question 1D, where it's talking about the decision trees.
Okay,
And it
yeah,
asks,
give me just a second to pull it up.
oh yeah, of course.
Okay, so homework 3. Okay, and so what was the number you were looking for?
Yeah, so for part D in question 1, it's
Okay,
asking if we should
1D.
standardize or normalize.
Yeah.
But I
Oh,
thought
yeah,
that
okay.
decision trees, you don't have to.
Yeah, okay, great question. Okay, that is worded very awkwardly. So that is not, the question should not be, do you standardize or normalize your data? It's a question of, should you apply some kind of transformation like standardizing or normalizing or not? So yeah, so
okay.
that's worded very, very awkwardly. And guys, actually, please take note of this, because please take note of this. Yeah, so again, so she's asking specifically about 1D. Should we standardize or normalize our features? Yeah, so the answer is no, you do not. The answer is you do not standardize or normalize. And that's just meant to, that or is sort of an inclusive and not a, do we do A or B? It's, do we do A or B or none? So, and the answer in this case is none. Yeah, so thank you.
I was
wow,
like running in circles.
Oh
I was
my
like,
God,
am
I'm
I
so
not
sorry.
understanding decision trees?
Yeah, no, you are understanding them better. Okay, you know what? Actually, sorry. Let me take a note about this. I need to update. I'll post a note on Piazza about that. 1D. None is an option. And by the way, Charles, I'm sorry. I did not respond to your email, but I got it, and that will not be a problem. Yeah, so I have received it, and I will handle the submission.
I had a question on problem 5, like the principal component analysis.
Mhm.
I'm not really sure like what D, like what to respond with 5D
Okay, sorry.
or maybe 5B.
Oh,
as
okay, yeah, of course. Okay, so let's work through that as a team here. So let me just pull that up in case guys aren't familiar with that. I'm just going to share the screen on this. Okay, so this is a principal component analysis, and it's basically asking for each of the situations below, would PCA work well or would it not work well, and explain why. And so, let's just run through this really quickly. Data with a linear structure. So that's kind of a conceptual thing, but it basically says that your data can be sort of broken down into sort of linear components. Well, literally that is what PCA is designed to do. So intuitively, you would think it would work well. For B, data lying on a hyperbolic plane. So does anyone know what a hyperbolic plane is? So let me just Google it. Hyperbolic plane. So hyperbolic planes could look something like this. It's the opposite, if you will, of a linear sort of thing. It's something where your data kind of looks like this. So do you think, where's my homework? Okay. So do you think PCA would do well with that?
I don't think so.
Yeah, so that's good instinct, right? If you're trying to draw sort of your principal components along that variance, you're not really actually capturing a lot of useful data by doing that way, because your data is just kind of all over the place, and PCA really isn't designed for data structure in that way. So, okay, so that's B. C, a data set containing non-normalized features. So, so data that hasn't been scaled or normalized. Do you think, is PCA susceptible to scale issues?
Yes, it would not work well. I also had a question. Like, I know that in lecture, if you don't have like very linear looking data,
Mhm.
use like the kernel, so you have like a non-linear like boundary or something.
Mhm.
Is that like applicable to B?
Sorry, I'm not tracking that.
Um,
Didn't say it's
like
wrong. I'm
I
not sure.
remember like something in lecture where you can use like the kernel trick
Mhm.
to like get like a non-linear or handle this non-linear case.
So it's the idea that you sort of do kerneling to kind of make data that's hyperbolic sort of more linearly oriented, so then you could run a PCA on it.
Yeah.
Oh, that's cool. I hadn't thought of that, but yeah, I think that would work. That's actually really cool. But for the sake of this homework, we wouldn't expect you to answer that.
Okay, thank you.
So, yeah. So, but to your initial point, yes, because we're looking at variance, and variance does depend on the magnitude of the features. If you haven't normalized your data, it could be there could be significant skew in terms of how the resulting principal components. So, and then I think this is getting to what you were asking for 5D. Data set where each feature is statistically independent of all others. So taking kind of a half step back. So why is it that we do principal component? Like what's the reason we would do it in the first place? What's the goal of running a PCA?
To reduce dimensionality.
Yeah, perfect. So dimensionality reduction. So because it's the idea that like if your dimension, if your data frame is too overly hyper dimensional, it leads to overfitting, and that's a problem. So then the question that kind of arises is, why don't you just run, we had the question, like, why not just run a linear regression, run, generate your t statistics, your p-values, just look at what features are correlated, keep those, drop the ones that aren't really related, and just prune your data set that way. Why do you have to do this PCA business? So, okay, so long answer short, the answer for that is because oftentimes your features are not statistically independent. And in fact, though that data is reflective of an underlying model. So, we gave the example actually just now when we were looking at the trucking data. We were looking at like the method by which they signed on, and saying, that itself may be not useful, but it's part of a bigger pattern, which is the person's underlying age. And there might be other data there, like for instance, the if we have like the neighborhood they live in, well, certain neighborhoods with, let's say, may attract younger individuals, so maybe, so the point is those features aren't necessarily statistically independent because there's that underlying feature, age, that isn't fully captured explicitly in your data, but is an underlying component in your data. And so the problem is, if you trim statistically dependent, codependent features, you're actually kind of losing that underlying pattern. And so the whole idea of what principal component analysis does is it says, okay, well, let me take your data and let me reframe your data, or at least the variance of your data, the pattern of your data, in a form of statistically independent principal components. And by making them statistically, so by sort of recasting them along those statistically independent axes, it allows me to sort of trim them without losing that underlying connected pattern. So kind of bringing it full stop, going back to part D. If your data set is already statistically independent, then there's theoretically no advantage to running principal component analysis, because the outcome of a principal component analysis is a series of features that are statistically independent of each other. And you've already achieved that. So there's literally no advantage to a PCA over what you already have.
Okay, that makes a lot more sense. Thank you.
Cool. Okay, what else is going on? Okay, well, we are closing in on 150. So I'll give you all another minute or two. I will stop recording though.